Hello everybody, this is Algebro here, whether you're seeing this on Dogmathics or Algebro's channel. This is posted on both of our channels and we both solve, this is a video edited together where we both solve the same problem. And yeah, let's get to the video. Dogmathic is first, then I am approximately halfway into the video.
What is happening, everyone? Today we are doing a collaboration video with Algebro, ALGEBRO1. Check out his YouTube page. He is the most prolific math poster in the world by far. He posts a math video daily, so please go subscribe to him. He is the Euler of YouTube math. His stuff is really interesting, so check him out, please. The way this is going to work is I'm going to solve a problem that he sent, and he is going to solve it. We're going to edit these videos together, I think, and I have a feeling we're probably going to solve this the same way, but who knows? So when I saw this, I thought a little bit about I did a previous video on how to turn base 10 numbers into binary and binary into base 10. So this reminded me a little bit of that because I'm going to use that technique. Not the Euclidean algorithm, of course, but just the way to write a base 10 number. And so what we have here is ABC is a 6-digit number. And so each of these, I should have said, these are integers, right? So we're not going to have a 6-digit number that's 1, 2, square root of 2, pi. Like that's not what we mean. It's a 6-digit number. The whole thing's a number. So we can write this in base 10, where ABC are integers, by doing this. So I'm going to multiply each of these unknown integers by 10. So C times 10. And then we do descending powers from the highest to 0. So in other words, we go to 0, 1, 2, 3, 4, 5. Okay. So we have a good start here. A times 10 to the 5th, B times 10 to the 4th, C times 10 to the 3rd, and so on. Now we have 2 A's, 2 B's, 2 C's, 2 A's, 2 B's, 2 C's. So let's group these. So I'm going to group them. So we have A times 10 to the 5th plus A times 10 squared. So that's this guy and this guy. I'm going to group the B's. And plus B times 10. I'll just put the 1 there in case you're watching, don't know where it went. Times 10 to the 3rd plus C times 10 to the 0. Okay. So now we're just going to factor, right? We're going to factor out the ABC. So we have A times 10 plus 10 squared plus B times 10 to the 4th plus 10 plus C times 10 to the 3rd plus, now 10 to the 0 is just 1, so this is 1. All right, so now we are here. So we can see that each of these, if we think of A, B, and C as variable, so to speak, we can see they'll each have at least 1,000 in common, right? Each has 10 to the 3rd in common, or 1,000, right? So this has a 10 to the 3rd in it, this has a 10 to the 3rd in it, this has a 10. I'm just looking at what's common. However, well, let's multiply this out a little, as I think if we look at this last term here, 10 to the 3rd is 1,000, so this is really 1,001 C. So 10 to the 5th plus 10 squared. And these are just powers of 10, so they're not too hard to calculate. 10 to the 5th is 100,000. 10 squared is 100. 10 to the 4th is 10,000. Of course, 10 is just 10. So this is 10. Of course, 10 to the third is 1,000 plus 1 is, so we got 1,000 plus 1. So this is 100,100. This is 10,010. This is 1,001. All right, so we can rewrite this as 10 or 100,000 and 100 plus 10,010. These are sort of interesting looking, right? I sense a pattern here. So that's 1,001 C. All right, so we have this. This is our 6-digit number. Whatever A, B, and C are, that would give us the 6-digit number. Now, again, what we have to prove here is that it's divisible by 13. So, any good algebra problem, we always look to factor. We know 1,000 will come out of here, right? But we also know possibly that 1,001 will come out of here. So let's see, 10,100 divided by 1,001, that's 100. 10,010 divided by 1,001, that is 10. Of course, 1,001 divided by 1,001 is 1. So 1,001 is nice, and it'll be nice for obvious reasons. So that leaves us with 100 times A plus this leaves us with 10 times B and C. Okay. So why did that matter? Why didn't I just take 1,000 out? I suppose we could just take 1,000 out, and then we could have taken other things out, possibly. But the reason that 1,001 is nice, well, 1,001 is equal to 13 times 77 plus 0. So this means that 13 divides 1,001. In other words, 13 times 77 gives me 1,001. There's no remainder, so it divides it by integer division. So now 1,001 times any multiple is divisible by 13, as long as this multiple is an integer, which A, B, and C are integers. So 100 is an integer, 10 is an integer. We add those, we get an integer, of course. So this means that 13 will divide 1,001 times any other integer. Therefore, 13 will divide 1,001 times 100A plus 10B plus C, precisely because this is an integer. And that means that 13 divides A, B, C, A, B, C. And that's it. The trick here was to write it as a base 10, so multiples of 10 to some power, factor out 1,001. I suppose any multiple of 13 that they all shared would have worked, but 1,001 was nice. It's right here. Not too bad. And that's it. So that's the end of the proof. Not really formally written, but that's it. ABC, 6-digit number, all of them integers, is divisible by 13. So yeah, that's it. Again, go subscribe to Algebra. He's awesome. I really get a kick out of his videos. He's really prolific, and he solves problems from various areas of mathematics. So go check him out, and thanks for watching. I'll talk to you soon.
Okay guys, welcome back to another video. This video is filmed in collaboration with @dogmathic. I don't know if I'll be before or after his section, but I believe this video will be edited together. But basically this video asks to prove, or this question asks to prove ABC is divisible by 13, where ABC represents the 6-digit number with C in the ones place, B in the tens place, blah 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 blah. Okay, so first off, let's just find an example. Let's do 5, 4, 2, 5, 4, 2. And we're saying 13 is divisible by 5. 13 divides 5, 4, 2, 5, 4, 2. Okay, so let's divide 13 by 5, 5, 4, 2, 5, 4, 2 by 13. So 5, 4, 2, 13 times 4 is equal to 52. So if we can subtract 52, 0, 52, 0, as we know this will be a multiple of 13. So we get 2, 2, 0, 2, wait, what? 2, or 0, 2, 2, 0, 2, 2. And then we subtract 1, 3, 0, 1, 3 to get 9, 0, 0, 9. And then subtract, what do we do from here? So 13 times 7, let's try, is 91. So 13 times 6 is 60. 60 plus 18, which is 78. 78, 0, 0 gives us 9, 10, 8, 2, 1, 2, 109. And then we see, yeah, okay. So we see 2109 is equal to, or 1209 is equal to 1300 minus 91. And we know that that's equal to 13 times 100 minus 13 times 7. So that is divisible by 7. It's equal to 13, or divisible by 9. It's equal to 13 times 93. Okay. So, yeah. Just as a base case, we see that this is divisible by 13, and we generally have the same repeating digits until we got here. So, yeah. Why don't we just do a general representation? ABC is equal to A times 10 plus A times, or plus, I'm not going to put the powers in yet because I want to figure that out later, times 10 plus C times 10 plus A times 10 plus B times 10 plus C, and that's just going to be plus C. This is going to be B times 10 to the 1, to the 2, 10 to the 3, 10 to the 4, 10 to the 5. Okay. So this is 10. Shoot. This is C plus 10B, 100A plus 1000C plus, here we go, 10,000 B plus 100,000 A. So if we combined all these, we get 100,100 A plus 10,010 B plus 1001 C. Okay. Let's see. Okay, so if we know if this entire thing is divisible by 13, its mod 13 is equal to 0. So that means that if we take all of these mod 13 and add them up, they should equal to 0. So 100,100 A mod 13, or yeah, when you sum them, plus 100,100 B mod 13 plus 1001 C mod 13 is equal to 0. And of course this is mod 13. Because this will probably equal like 13 or something. Or 26, I don't know. We'll see. Okay. So, if you look at this actually, this is 10 times... This number here is 10 times this, and this is 100 times this. Okay, why don't we just look at this? So, this mod 13 is equal to... Let's see, is this divisible by 13? What could we do? We could do 9, 1, 0, which gives us 1, 10, 10, 9, 0, 9, 0, 91, which 91 is divisible by 13, so we get 0. So this is divisible by 13, so this goes to 0. If this is divisible by 13, this is divisible by 13, because this is 10 times that, so that's 0. Now if this is divisible by 13, this is divisible by 13, because that's 10 times that, so this is 0. Okay, so now we've shown that this is divisible by 13, because they're mods 13. This, and this mod 13 all go to 0. Yeah, so, if this is at the end of the video, I'll see you guys tomorrow. Thank you guys for watching. But if this is at the beginning, you'll see Dogmatic's version right after this. So, bye guys. Bye.